Good afternoon, everybody, and welcome to this celebratory occasion where we're going to celebrate Hans Michael's achievements, and in particular his appointment to full professorship at the University of Southampton after a really exciting journey. My name is Stephen Holgate. I've been here a few years. I came in 1975 before all this was built, and it's evolved a lot since then. But even when I arrived in 1975, lung disease was a major activity in the new medical school, which by then was only 4 years old, or 5 years old. And the founding professor then was Professor Jack Howell, and he came from Manchester originally, and he and a man called Roger Ortunian discovered a drug called sodium chromoglycate, which was used to treat bronchial asthma and allergic diseases. So he was already here with another man called Donald Atchison, who set up the medical school here, who was very involved in occupational health in many forms, of which, of course, lung health was a big deal, especially in those early days where industrial exposures were problematic. But we're not here to hear about the history of Southampton, we're here to hear about the history of Hans Michael. And you're going to hear some exciting things, I think, today. I was asking Hans Michael when I first met him because I can't remember. I can remember very much this sort of geography, because obviously Hans Michael came from South Africa here. He joined us in July 2001, having spent 4 years at least, if not longer, in South Africa, in Cape Town, in Tygerberg, and the Stellenbosch Hospital there, which is a very famous, Stellenbosch University, which is a very famous university, and one or two people who have come to Southampton and gone elsewhere since were at Stellenbosch, and I got to know them rather well, and they worked in my group as Hans Michael did when he came over. So this is like a family. And what's amazing, and I was just saying to my cousin Diana over here, who's in the audience, you know, people who decide to move away from their home countries to go to somewhere completely different, in a completely foreign environment, are people who make progress because they're willing to take on challenges. And people who don't take on challenges shouldn't do that. The people who don't, you know, want to come to countries and take on different challenges shouldn't do that. But people like Hans Michael, you know, has this extraordinary ability to be able to adapt to the environment they're in, make a lot of friends, as he and Gehilda have done, and that's wonderful, and create a real environment around themselves, as well as the community that they live in and the places that they work. And this is what this wonderful family have done, as you will hear about a little bit later on. I'm going to put a slide up, which I think is up there really, which kind of goes just a bit before Hans Michael arrived here, because in 2001 we published this paper in Nature which described the first new gene that was associated with bronchial asthma. And of course we all know that asthma and allergy run in families, so this was the first novel gene. And I thought you'd be interested to know that that piece of research cost $67 million. Now to do the same these days would probably cost you about $5 million, something like that. So $67 million is how the human genetic process has become so much more in line with cheaper ways of molecular technology. And it was advertised. And people who were involved in this, Joanne Clough, who eventually became a psychotherapist. So there may be an answer there for you, Hans Michael. Stuart Rourke, who came from South Africa, who Hans Michael knew, and he went to Australia and went to Monash University, where he leads in pathology there. And my good friend John Holloway, who's still here in Southampton. There's still a few of us left, you know, but anyway. So if I go on to the next slide, which I'm going to try and do by pressing these buttons. Is it this one I press? Which button do I press? You will know, because you're an expert.
And we put it into slide mode.
That's lovely, thank you very much. Yeah. That's
Just
good. Oh, you can see it
down.
now.
This
Yeah.
one down.
Thank you. I'm an old man, so you'll excuse any changes. Well, this isn't the first award that Hans Michael has got, because we're all very proud of him, of course, because he's here and done what he's done and he's doing what he's doing. But this is really his home country, really, acknowledging the amazing achievements before he really came here. But since he's been here, he's kept this amazing relationship with his home country in Austria. And it's just so lovely that they've recognised that, and this just captures that lovely spirit that was engendered, I think, by your visiting that and doing and helping, I think, a PhD student there, which is what you have been doing since you've been here, so that's nice. But what I didn't know, and I've only just found out, I know why you're interested in this molecule now, because of all of this, and your father, and the woodwork, and your ability to carve, and the fact you're a master carver, or he says an apprentice master carver, I don't think he is anyway, but he is, and that you turn out these amazing carvings. And when I looked at it, I couldn't believe it. It just looked like the molecule you've been working on all these years here. We've got an explanation now. Why? And look at the bottom. Since then, he turns out 40 or 50 of these things a year. So maybe if you can turn out 40 or 50 papers a year on this molecule, that's going to be a good example. But I won't take any more time up, just to say what a huge pleasure and what an honour and a privilege it has been to have you with us these last 24 years. Hans Michael, we're absolutely thrilled that you're able to give us this talk in your new professorship, and we so look forward to hearing from you. Thank you.
Thank you very much, Stephen, for this kind and warm introduction, and it's really a pleasure to have you here, and you're a very special person to me, and thank you for this personal introduction that you did. So I also want to welcome you all who are here present in person. It's great to have you all here, some of my friends, some of my colleagues, some of my family as well, and also the people who are online. Lots of colleagues, lots of family from Australia, Austria, America to South Africa will be online, and great welcome and thank you for joining us. But I'm particularly really pleased to have my parents here, and I want to say, Mama und Papa, danke, dass ihr hier seid, und es ist voll nett, dass ich freue mich riesig, dass ihr hier seid bei dieser Vorlesung. So sorry, I'm a bit emotional, but it's really a great pleasure to have them here, because they're actually now in their late 80s, and they still travel. They visit us everywhere in the world, wherever we went. We went to South Africa, they came to visit us, went to the States. They don't speak any English, but they've still traveled. It's fantastic, the spirit that they have, and the energy. I would like to have the same when I'm in their age. So, I have wanted to take you through a brief slide here. Sorry, I'm just trying to get the pointer going. I had it earlier. Yes, an outline of my talk today. Initially, I want to tell you a bit about why asthma and the burden of asthma, and then some key influences in my personal life. Then I want to take you through all the A's in my life. Austria, and my time as a medical student and my training in Graz at the University of Graz. Africa, Cape Town, my specialist training there, my first asthma research with Philippe Bardin there. Angleterre, sorry it's French, but I'm learning French at the moment as well, which is quite interesting because my little nephew brought me on Duolingo, and now I'm learning French. And where I started my PhD studies and studying the role of ADAM33. And then I was fortunate to get an MSc Clinician Scientist Fellowship, which took me then to Cincinnati Children's Hospital in America, and then back here to Angleterre, to England, where we continued our research in ADAM33, and now with colleagues in the States trying to develop a new treatment for asthma. And then obviously I'm also involved in some clinical studies and want to give you a few slides about my vision of my future research and my vision for probably the clinical perspective of asthma. And finally, there will be a few slides of gratitude to my mentors, to my friends, and to my colleagues, and also to my family. So the whole journey, why asthma? On a train journey from my hometown in Vöcklerbruck to Graz, I met this lovely young student, a lady. Her name was Gerald, and she later became my wife, and she suffers of asthma, and her family suffers of asthma. She has a sister, she has relatively mild asthma, but her sister has moderate to severe asthma, and one of her distant relatives died of an asthma attack at the age of 19. And this inspired me to pursue a career into asthma, to try to find maybe a new treatment or a cure for asthma. So we know about asthma, it's the most common disease in childhood, chronic disease, and it's very common in adults as well. The main symptoms are you have wheezing, you have coughing, you have a tightness of your chest, and people also can have bronchial hyperresponsiveness or twitchiness of the airways. And the main causes for triggering the asthma attacks are exposure to allergens like house dust mites or pollens or viral infections. And here you can see a diagram of an airway of a patient with asthma that has been remodeled. And here's a normal or healthy controlled airway. So you see there's thickening of these airway walls, there's more mucus in these and a smaller lumen, so you have inflammatory cells, and there are lots of smooth muscle cells around these airways. So I brought a picture because the pictures are better and you can see it here as well, but if you can see here, if I fold this is a section through a lung, an airway of a healthy control. And I don't know if you can see it, but I will tell you about it. So the lumen is quite open. There's the lining inside of a single layer of cells, which are quite nice and smooth. And there's some smooth muscle around it, and also some mesenchymal structural cells, like fibroblasts and myofibroblasts. And this is, if I turn this around, you see what happens in a patient with severe asthma. And this was after a patient died with severe asthma. You can see there's a smaller lumen, lots of mucus producing cells in these airways, and lots of smooth muscle around it, as well as structural cells that actually make these walls much bigger. And this is what happens in a patient with asthma. So in order to experience what it means to be an asthmatic, I've handed out some straws, and I would like to ask you now to use the larger straw, please, first, and breathe through it in and out slowly. Should take a photo actually. Smoking in the lecture. So you will feel actually it feels quite easy to breathe through the larger straw. Now please change to the smaller one. You feel it's much more difficult to breathe in and particularly to breathe out. And this is what it feels if you're an asthmatic and you have an asthma attack, a coming asthma attack or a severe asthma attack. So I hope you feel what our patients can feel when they have asthma. So worldwide, how do we know about asthma? What is the burden of asthma? About almost 300 million people suffer worldwide from asthma, and in 2019, about 500,000 patients of asthma died. And in the UK, we have around 7.2 million people with asthma, 1 in 12 adults and 1 in 11 children. And every 10 seconds, if I count up to 10, there's a person in the UK who has a severe asthma attack. And every day, 3 people still die from a severe asthma attack in the UK. And it costs the NHS about £3 billion every year. In the United States, we have 28, almost 30 million asthmatics, and 10 people die there every day of an asthma attack. And it costs the US about $80 billion US. So it's a good reason to do research into asthma. But in order for you to understand my journey and my background, I have to go back to the 12th century. In 1200, my forefathers and relatives moved from Germany at the border to Rhine-Main-Mosel area, so similar, close to where the royal family comes from, they moved to Romania. And they were settled there, and they had a German community of about 500,000 people at their height. And these were called Siebenbürgen, or the Transylvanian Saxons. So they had a duchy, and they had a coat of arms as well. They had their own German main language, and also an old dialect, which we still speak at home with my parents, which is very close to the Luxembourg language. So when we go to Luxembourg, I can talk to them, and they just say, "Your Luxembourgish is a bit old, but otherwise we can understand you." So this is some pictures of my great-grandparents when they were married in the 1800s, and I was still very close to them. I actually met them, and they were quite old when they died. These are my dad's parents when they got married sometimes in 1900, and then these are my parents married in 1963 in Bistritz in Transylvania in Romania. So why am I telling you this? So my parents, as a German minority in Romania after the Second World War, were not allowed to actually go to higher education, and they were prohibited to do higher education. So when they came to Austria in 1964, and when they had us three siblings, they always encouraged us to go, and if we were able to go to university. So I was born in Vöckerbruck in Upper Austria, just after they moved in 1964. And here's a picture of my uncle when I was 1 year old, when we visited our homelands in Romania, where still the houses stand, or at least one from my mother's grandparents' side, and also the land which strictly would still belong to us, but we were disowned, and it's very difficult to get this back. So the picture I show here with my uncle is because he wanted to study medicine, but he was not allowed to. And this is probably a reason why it inspired me to go for medicine myself. Then this is a picture when I was about 4 years old. I had, as a young child, I had always a pseudocroup, and I was admitted to the hospital. So this is a disease of the upper airways, and then you get this barking cough. And at the time when I was a child, there was no good treatment. I was often for weeks in the hospital under oxygen tents, and I didn't like it. But my parents took me after I came out again from the hospital to a photographer to take some photos. And when the photographer came out, he had a white coat, and I started crying. And my parents didn't know why, but I didn't want to go back to hospital because I thought he was a medical doctor. But another reason why I might have gone into medicine. So I was brought up in a really caring family environment, and you can see here my two siblings, my sister Sonja, she's 5 years younger, my brother Gerhard, who is 10 years younger, and we always joked with the parents they had the communist 5-year plan. So this was when I was around 14 years old, during my confirmation, when I actually decided as a growing up or adolescent to give my life to Jesus and to follow him as my Savior and as my Messiah. And I was fortunately and encouraged by my parents to attend high school or secondary school and do my school leaving exam in 1983. This is my class, and then moved on from Upper Austria to the capital of Styria, Graz, where I started as a medical student. So in 1986, as already mentioned, I met my lovely wife, and we got married in 1991. We met on the train, as mentioned earlier, and it was great to have her on my side. But already as a medical student, I had some connection with Britain. I was part of the Christian Medical Union in Austria, and we had a link with the southern universities in England, and we frequently came over with a friend who is also here in the audience, Andrew, and he introduced me to Bill and Shirley Lees. He was a medical doctor and she was a linguist, and they both spent 20 years, I think, or longer, in Borneo translating the New Testament for a local tribe there, and also changing their complete health system from a several days a week drunk tribe to a completely healthy society then, becoming Christians. And also he arranged for me to actually get an elective period in Battle Hospital in Reading, which doesn't exist anymore, but I spent there 9 weeks as a medical student and got to know the British way of teaching medicine, and I got really fond of this. Another important couple in our life is Paul and Di Alcock, also here in the audience. They came to visit our friend Andrew and also visited us and spent some time with us. And I told them during this time that I would like to do some research into asthma, because Gerhild was suffering from asthma, and would like to do a PhD in the UK. And Di told me, why don't you have you contacted my cousin? He's a professor of asthma in Southampton. So I said, what is his name? So she said, Stephen Holgate. So I said, yes, I wrote already to him because I knew him from the literature, and he had replied already, and he was quite open for me to come over to do a PhD in Southampton. So this is the University of Southampton, of Graz. It changed a lot. This was founded in 1585, and this was my view, or almost my view, from my house where I used to live. You can see the house where I live. This is here, and this is the preclinical building, which has been now torn down and has been changed. But when I started in 1983, we were 600 medical students, and this was the main lecture theatre. And when I qualified, we were 12. So there was a big dropout in medical school. But still, there were too many medical doctors when I qualified. Here is a Professor Thomas Kenner. He was the professor of physiology, and he inspired me as well, a very lovely, caring man, and we became good friends as well. Here is the Anatomy Institute in Graz, and this is Professor Thiel and Professor Ryman, and here's the dissection theatre, which has now all gone and moved into a new building, but you can see here we were taught anatomy. These are some typical lecture theatres, and again, two people that inspired me: Helmut Denk, a professor in pathology, and Günther Kreis, a professor in internal medicine. Both were trained in the States and brought back some of this Anglo-American way of teaching, and I was great impressed and inspired by them. So these lecture theatres don't exist anymore, but at my time they did, and they were brimming full with students. We always went to all the lectures, because the school, we didn't have a medical school, we had a medical university, which meant you had to go to the lectures, and you had to take the textbooks and then learn from them and from the lectures. And when you thought you were ready for the exam, you applied for an appointment with an examiner to go and do the exam. And then the exam was a public exam. It wasn't just you and the professor. It was a public exam, and everybody could come and visit. So often there were hundreds, 200-300 students in the audience, and there could be even from the general public there. My anatomy exam, we had a whole corpse in the lecture theatre, and I was given the lungs, and I had to dissect the lungs, and I had to make a diagnosis, a microscopic diagnosis of the lungs. So it's quite probably challenging for some students nowadays to do this. And there were 200 students watching me. And then you had to give answers, good answers as well. But this was also a way of learning, because I also attended all these exams as an audience, because I learned from the other students. So in 1990 I graduated as a medical doctor in Graz, and on my invitation to my graduation I wrote this prayer by a Jewish physician from the 12th century. Morning prayer of a physician. I begin my work, help me with it, Lord. Otherwise it will be in vain. Let the search for truth and love for mankind guide me and protect me from striving for profit and recognition. So this has guided me through my medical career, searching for truth, but also loving mankind. And it's something that I'm still fond of, and I hope I will give this forward and can hand this on to other medical students. In 1999, after I qualified, I also had to go to do my military service, and during my military service I had some time on my hands and I could prepare for my apprenticeship diploma exam. And the reason for it, because my parents had a business, a small business, a joinery and carpentry business, and you can see here my dad and my brother in the workshop. And then I passed this exam during my army time. I think my dad was almost as proud about it as I had about my medical degree. From 1992 to 1995, I trained as a general practitioner at the University Hospital in Graz. And then I was at a road, at a crossing of the road and crossroad, sorry, and had to decide, would I stay in medicine or would I leave medicine and go and become a carpenter and join and work and take over the business of my dad. And the only option that I had was to go to an Anglo-American place to learn more of clinical medicine, at least for me then. So we went on a holiday to South Africa to see family and friends there, and during this time I applied. I was bullied by my friend to go and have an interview with the professor of internal medicine at Cape Town, both schools, medical schools. And lo and behold, a year later I got a phone call from them and they said, "We have a post for you, please come and join us." So within 3 months, we packed everything up, bought a one-way ticket, and then 3 weeks before we left, I thought, Gary, I think I should phone the embassy and find out if we need actually a working permit. So I phoned them and they said, yes, obviously you need one, and you have to apply within Austria in Vienna, and you have to come and see us. And they said, but I'm flying in 3 weeks' time. I said, yeah, you have to cancel your flight because it will take at least 3 to 6 months. So off we went a couple of days later to Vienna. I had all the paperwork done. I got my health profession council registration. I got the appointment letter from Tygerberg Hospital, and they were quite astonished that we had this all. And they said, but still we would advise you to cancel your flight. And it will take about 3 to 6 months' time. I said, no, we're not cancelling, we are flying, and you can send us the working permit to Cape Town. So they said, we're not sure if this is possible. So anyway, we went home to Graz again, and the day later they phoned us, they said, the paperwork is finished and you can come and fetch it. So I said, we don't have time now to come, but we will do it on our way to the airport. We pick it up when we go to the airport. And this actually confirmed to us again this was the right place to go for us to a certain extent, to go to South Africa. This is a few pictures of Cape Town, a bird view of the Table Mountain, the famous Table Mountain, the two oceans, the Indian Ocean and the Atlantic Ocean. And you can see this is the view from Blueberg Strand, the famous tablecloth, the Table Mountain, and the cable car onto the Table Mountain. The Blueberg Strand is famous for its wind. This is why it's called blue, which means in Afrikaans blowing. And you can see this in our hairstyle and my brother's hairstyle here as well. My parents came to visit us as well in Cape Town in South Africa. And I put this picture in particularly because this was our only connection back to Europe, a telephone. We didn't have mobile phones. We didn't have an email. We couldn't do Skype or Facebook or WhatsApp. It was a telephone. It was really expensive. So we rarely phoned our parents and actually often asked them to phone us because that was cheaper for us. So these are more pictures of Table Mountain here, and then you can see famous beaches. Here's Camps Bay Beach in South Africa, and this was always packed over Christmas. Some pictures of the wine farms around Cape Town and Stellenbosch, famous for their excellent wines and excellent food, and I can strongly recommend you to go and taste some of these. This is now the University of Stellenbosch in Stellenbosch, and here's the Faculty of Medicine, this building here in grey, and then behind it in red you can see the Tygerberg Hospital, and they were connected, and here was the clinical training taking place. And here was the exams and the students' teaching taking place. Here you can see me in my dress code as a clinician. We had always a white coat. We had to wear a tie, and we had to wear trousers, not jeans, and shirts. And you could deduct it from tax, which was great. But I did quite well in my first year, which were called also the salt mines when I worked on the wards. So you had to work there up to 100 hours a week, and you were responsible for your patients 24 hours a day, 7 days a week. And when they called you in the middle of the night, I had to go out and had to go and intubate them and put them into ICU or whatever we needed to do with the patient. And I did well in my entrance exam, which was physiology and pharmacology, and then I was offered a training post from the initial 1 year that turned out to be then almost 5.5 years. And you can see me here in my study, and this was in the later years when we got a first computer, an old one from a friend. And but there was a lot of studying. We had exams every 6 months, 3 to 6 months in the subspecialties. So there was a 3-hour written exam in basic physiology and basic pharmacology, and a 3-hour written exam in clinical medicine in each subspecialty. And then we had a clinical case as well. And so there was a lot of studying in the night, and then early getting up in the morning at 7 or 8 o'clock to start and coming home at 6 or 7. So young doctors nowadays would not be able to do this anymore, wouldn't like to do this anymore. But so you find me then lots of time, you found me in this position here. I was really tired, and so I was in the Monday firm, which meant you had every Monday you were on call for 24 hours, and then you had to do every second and every third Saturday on call. And so often I went to the church services after my call late, and then I was sitting in church and I was sleeping mainly, and sometimes I was interrupted by my bleeper because I had to call back my nurse team or my junior doctors. But other than working and studying, I also had, when we had visitors, some time here in the flowers of Namaqualand. These are the wildflowers of South Africa during spring. It's unbelievable, it's amazing. Fields of different colors of flowers. Unbelievably beautiful, and some of God's creation that is excellent. I also learned to play cricket as an Austrian who wasn't used to it, and I think here we played against the consultants, and as far as I can remember we lost. But it wasn't because of me, because I was out very quickly. In 2002 then I qualified with a Master of Medicine in Internal Medicine at the University of Stellenbosch. And here is my promoter, Professor Philip Bardeen, who did a PhD here in Southampton as well, and moved then on from South Africa to Monash University in Melbourne in Australia. And this was my first paper, where I was a co-author about the association of rhinovirus and severe asthma exacerbation. And then these are some mediators that attract neutrophils into the, and also eosinophils that are white blood cells that play a big role in asthma. So in the last year of our time in South Africa, we had a burglary in our house. And it was when I was on call and Gail was on her own. And she caught the guy still in the house, but he ran out of the house. But she ran after him. Fortunately, she didn't catch him, he was faster. Because normally this wouldn't go out well. They attacked or killed. And so we didn't feel really safe anymore. And we put our feelers out to see if we could come back to Europe, and particularly to England. So again, I wrote to Stephen, and in Southampton I said, I'm now at the end, I've qualified in South Africa, and I would be happy to come now for my PhD. And we came over to Europe on a visit, and we came to Southampton and had an interview with him, and said, yes, I'm great having you, and you can come over. And then I said, but what is about funding? And he said, funding is not your problem, funding is my problem. It didn't turn out that way. I still had to apply for some funding. But I had to work for another year in South Africa, and in 2001 we moved from England to South Africa, and I started here on the 1st of September 21. So this was, I joined the group, and as Stephen mentioned already, at a very opportune time. This is when the group around Stephen and together with John Holloway discovered this novel asthma susceptibility gene called ADAM33 that is associated not only with asthma but also with the twitchiness of the airways in patients with asthma. And of interest was that Jeff Drazen, he was the editor of the New England Journal of Medicine, and his group already discovered a locus on the mouse, on the AJ mouse, that was also associated with this twitchiness of the airways. And it was at the same locus on chromosome 2 where ADAM33 was in the mouse, as was ADAM33 in the human on chromosome 20. And I brought here chromosome 20 for you. Not the whole one, but a part of it, and you can believe me, it's actually real ADAM33, and it just to show you that single nucleotide changes here in the gene can cause changes in association with asthma, and this is more or less to make this slide a bit easier to understand. So this codes a protein that exists out of 7 domains. And I brought a Lego from a friend of ours. We didn't have Lego, so I borrowed this to actually show you how this protein looks like. So it's a membrane-anchored protein. It has 7 domains. It has one domain, the cytoplasmic domain, that links it to the inner cell, and it actually conducts signaling to the nucleus. Then it has a transmembrane. The green thing is the membrane, and it has 5 extracellular domains. And the most important part, at least in asthma, is this metalloprotease domain with a prodomain. And this is enzymatically active, which means it can cleave other proteins. And by doing so, it can actually induce changing, which I'll show you later, in the airway walls of our mouse models and also patients with asthma. So this was my first part of my PhD. I was fortunate enough to get biopsies from patients with asthma and without asthma. So this is when we go with a camera into the airways of these patients. And this method was here introduced by Ratko, is here in the audience as well, where we take small pieces of tissue and then we can examine it under the microscope. And I stained it here for ADAM33, and you can see here this is where the smooth muscle bundles are in the airways. This is the lining of the epithelial cells, and ADAM33 was mainly expressed in these smooth muscle cells. And when I did some more fancy immunohistochemistry with fluorescent dyes for alpha smooth muscle actin for the smooth muscle and for ADAM33, they co-localized quite well. David Wilson, a colleague and collaborator who enabled me to get access to human embryonic tissue, allowed me to study ADAM33 in the human embryonic lung development. You can see smooth muscles are normally around these primitive airways during development of the ears, but ADAM33 is also around here, but it's more widely expressed. So it's in the progenitor cells, the stem cells, probably during lung development, and seems to play a role. Here with fancy microscopies here in red, you can see these stem cells surrounding these primitive airways. A colleague then from Italy joined us, Ilaria Puxeda, and she actually described for the first time a function of ADAM33 to be pro-angiogenic. So we had made protein that was enzymatically active, and also protein that had a mutation, so it couldn't cleave other proteins. And she placed little sponges drenched in these proteins in eggs that were fertilized, and then you could count the vessel that actually formed out of these sponges. And you could see here that in the presence of the active form there was increased vessel formation, and it was much less in the mutant form, and it was almost the same like in the control with vascular endothelial growth factor. We also used this then in our human embryonic lung explants, and you can see here increased vessel formation in these explants. At the same time, Dean Shepard from the University of California in San Francisco, he generated a knockout mouse, and this is always a good tool to study the function of a gene. And fortunately, this mouse was not lethal, and they developed quite well. They had the same amount of offspring like the wild-type mice, the plus mice. They had the same amount of litter and also average litter size. So this was a good sign for us, so it meant that we could probably use this as a tool for studying ADAM33 further. So another group in Korea at the same time published a paper where they showed that this soluble form of ADAM33 this one here, with the metalloprotease was increased in mild asthma and even more in moderate to severe asthma. And the more you had of this protein, the worse your lung function was as well, suggesting that this was a gain of function in the pathophysiology of asthma. My PhD, I submitted in 2008, and in 2009 was awarded my PhD under my supervision of Donna Davis and Stephen Holgate, and they will also have become my friends and mentors. And these publications allowed me then to apply for an MSc Clinician Scientist Fellowship. David Wilson was quite involved in training me how to do interviews for these fellowship, and I was awarded this fellowship in 2009. And this took me then from 2010 to 2011 to Cincinnati in America, where I had the privilege to work together with this bright mind, Jeff Witzert, in his lab in Cincinnati Children's Hospital, which was one of the top 3 children's hospitals in the US then. And this is a view from, it's a tri-state city, Cincinnati is a view from Kentucky, from Newport over the river Ohio into Cincinnati, and it's part of Indiana, Kentucky, and Ohio. And I worked in his lab with pulmonary biology. You can see here the lab, me here pipetting in the workbench, and it was real pipetting, not just staged one. And then here my desk as well. And Jeff has been a fantastic mentor, collaborator, and also has become a great friend in this time there. So this is the building as it looks now. So we had only 2 buildings, and now there's a 3rd building. It's huge, and this is just for medical basic research. So no patients are seen here, just basic medical research. It's a fantastic place to be. Lizzie Davis joined me as well, initially as a technician, and later she became a PhD student and postdoc. And she showed then as well, and we confirmed our Korean colleagues, that ADAM33, the soluble form, is increased in patients with asthma, and we also showed for the first time it's enzymatically active, so it can cleave other proteins. Again, confirming the gain of function, the pathophysiology of asthma. So in Jeff Witzert's lab, we were going to generate 2 mice. One was a double transgenic ADAM33 expressing mouse that was in the presence of tetracycline, which is an antibiotic. We could actually switch it on only in the airways. And it's a great tool to study the function of a gene and the protein. So you can see here when we switched it on with doxycycline, these are double transgenic mice compared to either the single transgenic mice. There was in red lots of ADAM33, and it caused the increase of alpha muscle around these airways. At the same time, in Cincinnati, we also got sperm from ADAM33 knockout or null mice from Dean Shepard's group, and we generated the knockout mouse again in Cincinnati, which we both brought over to the UK. These are some. This was a very fruitful time, and some where I could co-author some of the papers together with Jeff and his group, and involving also our engineers from Philip Turner and Nick Udall, who was a PhD student doing some micro-CTs for us on mouse lungs. In parallel to doing some research there, I also had the opportunity to join Jeff on his farm in Kentucky. Unfortunately, I couldn't find a better picture, and I'm really sorry about this, but we had a great time helping him moving cows around and horses, swimming in his murky lakes, which nobody wanted to go in, but we didn't mind, so we went and swam with him, and then we were shouting each other, "Ow, ow," and we said, "What's going on?" And said, "Oh, don't worry, these are just a sunfish. This is a sunfish." And then I took a photo of the bite mark, because they actually go for your molds and they suck on them, and you get these suction marks on your skin. But at least we were swimming with him. We also were in Kentucky, and it's be aware of bears is was new to us. We were just hiking there in Kentucky, and then we also made friends with the Amish people, which is quite untold of, and we were invited into their home, and they showed us around, and we did some collaboration with them, and I can tell you a bit later about this. And we also had some time together at the ATS in Denver, where we ate the best bison steak ever. In Cincinnati, we also joined a fantastic church out around the corner where we lived, and here are my parents when they visited us in the States. And it was this is just the entrance hall into the church, and the auditorium had 3,000 people seats. So this is a very small auditorium. But in the end, the church became small to us, and we made lots of good friends. Lizzie here joining us as well, one of the Christmas do. And we also got tickets from colleagues from work to the Open Cincinnati tennis tournament. It's the oldest tournament in the States. And we could watch really great players, Federer and Sharapova, in their semifinals and finals. It was an amazing time. So in end of 2011, we moved back with our 2 transgenic mice. Fortunately, they worked and they were survived to England, and we continued our studies here. And this Lizzie actually did here most of the work together with Joanne Kelly, who was then initially a technician and later became a PhD student and postdoc in my group. And here you can see the same picture again, Adam. When you express it, you have increased smooth muscle around these airways. And we did this also in human embryonic lungs. You can see here again, when you actually treat them with the protein, the metalloprotease, you have increased actually smooth muscle around these primitive airways. So this is the transgenic mouse, which showed these changes already without seeing any allergens. When we then challenged this mouse, when we switched on first ADAM33 and challenged it, we got even more remodeling. So more alpha smooth muscle actin was created in these lungs. And not only this, we also showed that the eotaxin increased, which is a chemoattractant for eosinophils that play an important role in the pathophysiology of asthma, and also they had increased eosinophils in their airways and also increased twitchiness of the airways. So a really good model of asthma, and seems to be driven by ADAM33. We wanted to then know, can we reverse this remodeling of the airways as well? So we put these mice for 8 weeks on doxycycline, and for 4 weeks, and then stopped it for 4 weeks and harvested them at 8 weeks. And then we had a control only for 4 weeks on doxycycline. And these are the results. So this is the double transgenic mouse. The 4 week showed increased remodeling of the airways, while the 8 weeks even more. And when we stopped it after 4 weeks, the doxycycline, you see it almost went back to normal, the remodeling. So pointing that this might be a good target for treatment. We also then used the knockout mouse and compared it with the wild-type mouse that expresses ADAM33. And here you can see when we challenged these mice with an allergen called house dust mite, we showed here in white is the wild-type mouse. They get increased deposition of alpha-smooth muscle actin in their airways, while the knockout mouse seems to be protected. And even more so when we measured the airway resistance as a form of this twitchiness of the airways, it seems that the knockout mouse here, again in grey compared to the wild-type mouse, was protected. And to a surprise, also the eosinophilic airway inflammation was suppressed in this mouse model. In 2012, a new lecturer joined us, Jonathan Watts from Texas, at the university as a lecturer in chemistry and RNA chemistry. And we were introduced at our church above bar, church in the center, and we met there. And I said, what are you doing? And he said, I'm doing research into RNAs and siRNA. I said, yeah, I use them as well for my PhD in ADAM33. So can we do a project together? I said, yes. We did a project. We applied for a small pump funding grant, and we got this. And then we got also a PhD student coming from Texas over, and she started this project. And she developed some really potent human as well as mouse antisense oligonucleotides, which we published and also filed a patent together with the University of Massachusetts and Southampton, where John has moved in the meantime. This is now latest work and still unpublished work, and this is part of the recent MRC DPFS grant that we were awarded together with John and our collaborators, Mr. Alzetani and Christian Ottensmeyer. And this is my team here, Maria Cusetti and Charity Tay and Rana Abdolkarim and Georgi Brashnikov. And Charity showed here when she took mice and took small pieces of the lung and cultured them in the presence of these 4 different compounds that can suppress ADAM33, we showed a significant suppression of ADAM33 after 3 days in culture. And Maria did then the same in human lungs, where we got lungs from lung resections, and she cultured them as well in 3 days, but 7 different oligonucleotides, and some of them show really potent suppression after a single dose after 3 days. We had then the idea with John in the States to generate a transgenic mouse, and they did this in University of Massachusetts, where they replaced the mouse part of ADAM33 with a human part. So we could use, or we can use now, our human compounds in a mouse model. And this is a first study here in Southampton. The mice had a long journey here to Southampton, but finally they arrived. A few of them got killed during the transit. But we showed here, after treating them with a single dose, just once in the beginning, 80% suppression after 3 weeks. So this actually allows us, probably, if this will be a future treatment for asthma, to treat these patients once or twice a week as an inhaler. Sorry. So another interest that I had was, what is the function of ADAM33 in lung development? So I looked here at wild-type mice, and I studied them from embryonic day 11 until 59 days after birth to see what is the expression of the gene in this during lung development. You can see here 2 important points. It actually increased in the early stages when the lungs actually start forming in the mouse. And this is the time when these early pseudoglandular, they called, lungs start to contract. So they pump fluid in it, and this actually enables the lungs to develop. And then again, after birth, when the lungs are inflated and they start breathing, you can see an increase of ADAM33. Together with my friend and Professor David Bassett in Wayne State University, we developed a model in the AJ mouse, which we challenged during pregnancy with ovalbumin allergen, and then we studied their offspring at day 4 after birth, and we could show that these small isoforms, or smaller forms of the ADAM33 protein, are increased already at very early life after birth, suggesting that it plays an important role in mothers who are asthmatics, and they can actually transfer it over to their offspring. This was then also confirmed to a certain extent with an experiment that we did in our double transgenic mouse, where we switched on ADAM33 from the time we actually mated these mice. And so all their offspring were expressing ADAM33 in the womb. Then we harvested them and looked at them at the day just before birth, 10 days after birth, and 28 days after birth. And you can see here, as alpha-muscle-actin as a mediator for asthma remodeling or airway remodeling was significantly increased at all stages of lung development, suggesting that ADAM33 in utero can cause already airway remodeling. This actually then allowed us to start a new study with my collaborator Matthew Coleman, who's here as well in the audience, and it was initiated by Marike Wandel and Joanne Kelly, where we started to collect samples, clinical data and samples, biological samples from mothers when they were with asthma and without asthma, when they gave birth through cesarean section. And this allowed us to collect not only the blood and urine, but also amniotic fluid, which we were interested in. And here Rana, one of my postdocs now, she did her first experiments, and she did staining for this ADAM33 metalloprotease in the amniotic fluid, and it seems to be significantly increased in the amniotic fluid from moms with mothers compared to non-asthmatic mothers, and it is also increased enzymatically active. Marike then, another gifted PhD student, started an experiment where we used our knockout mouse. But the knockout mouse, you can have a full knockout, or you can have also a half knockout. So they have, the mom has only half, you normally have always 2 copies of a gene. So the mom has only one copy of the gene and the dad has one copy of the gene. And when it made them, it results into offspring which have both copies of the gene, and it results in offspring that have no copy of the gene. And then we studied these when we actually challenged the mothers during pregnancy with house dust mite. And then we studied the offspring 4 weeks after birth. So these offspring had never seen any allergen, but only the mothers were challenged with allergen. And in the wild-type mice, we saw increased twitchiness of these airways in the offspring at 4 weeks, while in the knockout mice, it was completely protected. And further on, she showed them as well that this might have to do something with the structural changes of the smooth muscle. This is now the maternal environment pregnancy study. We have recruited so far over 220 patients or participants, and these are the clinical characteristics. We have also done some studies of using multi-omic analysis in 12 mothers with and 12 without asthma, and we're currently analyzing this with Asim Ziadi from Cincinnati, Rob Ewing from here in Southampton, and also Andres here from Southampton. And other than doing ADAM33 research and the maternal environment in pregnancy study, I'm also involved in the WATCH study under the leadership of my colleague and friend Ramesh Kukurelachi. And this has resulted, together with the University Hospital Asthma Services, in several, these are just a few of them, publications, and more recently one of our papers has been accepted to Lancet Respiratory Medicine. So what is my future research? We want to continue with our oligonucleotide studies as a new disease-modifying treatment for asthma. And our aim is to either to outsource or license our patents to some bigger industry, or start our own spin-out company from the University of Massachusetts or University of Southampton. We have already secured a web page which is called Pharmagen, but there's nothing on it yet. But we also want to continue with maternal environment in pregnancy study, where we have an invaluable biobank of matched samples from mums and their babies and amniotic fluid, as well as all their clinical data now of over 220 patients. Hopefully this will enable us as well to translate our findings here and start a preventative treatment early in life in susceptible babies that may develop asthma. The Wessex study is still ongoing, and we have now over 650 patients included and recruited, and it's an amazing tool that has allowed us to do national and international collaboration. And hopefully I will be able to use this as well in the clinical patients for first-in-human trials of our anti-ADAM33 oligonucleotides. To transform the future of asthma treatment, we must integrate cutting-edge and interdisciplinary research with clinical innovation and public health strategies. And one of these cutting-edge research has become, in the last few years, artificial intelligence. And this brings me I just put into ChatGPT, please draw a map of a future AI-dominated or guided clinic room for an asthma patient. It came up with these suggestions. An AI diagnostic pillar, central neural processors connected to all room systems, displaying real-time holograms of patients' metrics. Just amazing, just imagine. The patients walk in as a hologram here into this room. Robotic assistant offers smart inhalers delivery, assists with positioning during spirometry. Smart environment, temperature, humidity and allergen levels are auto-adjusted to patient needs. Amazing. Virtual assistant console for triage, education or psychological support using natural language artificial intelligence. So we are far off from this, but this is just a taste of what could be, what our clinics could be look like in the future when we make use of this new tool of artificial intelligence. So finally I come to my conclusions and to my gratitude slides, and I want to thank and acknowledge here people. We have here now strategy for the university, and I know that Diana likes this as well, and other people like it, and I actually have grown to it now as well, where we have this triple helix, and in the center are the people. And I fully agree that people are the most important in any research, and without people that surrounded me, that encouraged me, that mentored me, I would not have been able to be here. So I want to acknowledge and thank particularly Donna Davies, who was my day-to-day supervisor of my PhD, and Stephen Holgate during my PhD, and then also my mentors for my fellowship, MSc Clinician Fellowship. My students and postdocs, Lizzie Davids, who did most of the ADAM33 work, started with me in Cincinnati, and then Joan Kelly, who continued as well working as a technician and then with us, and then a postdoc, was a PhD student and postdoc, and Marieke Wandel, Nick Udall, who I mentioned already, an engineering student, and an Austrian student, Romana Mikes, who came over from Salzburg to work here with us several months in my time here. A big thanks to my current team as well, who on the MSc DPFS grant, Rana, she's also overseeing the MEP study, the maternal environment and pregnancy study, Maria Cosetti and Charity, and unfortunately Georgie had to leave us for personal reasons. And then a big thank you to all the collaborators, Jeff in Cincinnati, David Bassett, Wayne State University, and John and Wells in UMass, University of Massachusetts, and Matthew Coleman at the UHS. And a thank you also to the MEP, Watch and Study teams who recruit these participants for us, and it's fantastic work which they do, and I'm so grateful for all the teams. And also a great thank to the Brook Laboratory team who keep us on track and enable us to do our research within the Brook Laboratory, and then my UHS as well as University of Southampton colleagues. And finally, I want to acknowledge also the medical and engineering students that I have taught, because teaching them also taught me a lot. And I really enjoyed teaching these students, particularly in their first years, but then also examining them in their OSCEs and when they're quite nervous and they have to examine these mock patients or real patients. And I hope that I could share some of my enthusiasm and some of my background as well with them. Further on, I want to thank my colleagues, my mentors from Austria and my collaborators in Austria, my many friends in South Africa and colleagues who are still working there, and it has been a fantastic time there. And then obviously all my collaborators and friends and colleagues in the United States, some of them have moved on back to Holland and to France. And these are all the institutions I have been collaborating with over the last 24 years, and these are only valid with the faces that I put on here. People make these institutions, not the institutions make them. And the people that we work together and had the privilege to work together are amazing people, and it's a great pleasure to thank them in this way. And then the funding bodies that have been supporting my studies and continue to support it, a big thank you to them as well. So Stephen has already given away my little secret that I love working with wood, and I love to make arty things from wood, like fish. This is a research fish which I made for the Medical Research Foundation. It's now sitting in the main office. This is a canvas of my offcuts from the fish, which are called fish bones, and has made it into the Southampton City Sea Museum. And then I made fish and pigs and other things that are in private collections all over the world. The biggest one is in my house, but also some of my cousins. Harry Potter wands that work. And this is all under the trade name of Carrot Bird. And there's a little story about it. This is our godchild, Abby, when she was 4 years old. She drew this little picture, and then I was given it as a present, and I digitalized it, and I called it Carrot Bird, and this is my trade name for my woodwork. And we actually all went out, also we're doing some clothing as well. And then my parents taught us how... Oh, yeah, this is a fish, and I can hand it around. Sorry if you want to touch it. You need to touch these fish, and then they become alive, and show you actually what you can do with them. My parents actually introduced us to making Baumstritzel. This is something that is done in our family for hundreds of years, And we actually used it in South Africa and in America and in Southampton as well. And the labs were always invited to Baumstritzel, and they always enjoyed it. We started a little company with the help of the Amish people. They made these wooden cones for us in the States, and we tried to sell. We were not very successful, the kids, but it made it into a famous cooking book as well called Torta Strizzare. And otherwise than doing things over the barbecue, my wife and I love running. This is in the woods of Austria, and this is my lab in the common. It looks like a big Dane a bit. And this is, we like hiking in the Austrian mountains, but also in the countryside in the UK. And one of the favorite things is swimming in Austrian lakes. And you have to do this once. It's unbelievable. It's like swimming in champagne, crystal clear. The water, you can see the water, they can drink the water with its drinking quality, and you don't get sick. So I want also to thank my Creator. Through him all things were made. Without him nothing was made that has been made. And I had this great privilege. I don't know about the Milky Way and about the microcosmos, but I had the great privilege to look a bit into this microcosmos, the genetic code that makes up the life, and that God created this code and this language, and that from a sperm and an egg and dividing cells then makes something like this, our little nephew Karl, when he was born. It's an amazing, and I'm so thankful to being able to follow a little bit of God's thoughts in his creation. And then a big thank you goes to my family, my great-grandparents, whom I still met, and I spent lots of time with them, my mom's parents and my dad's parents, and obviously my parents. Und danke, dass ihr hier seid wieder. Ich freue mich riesig darüber. And then my sister Sonja and her husband Ulrich, and my nephews Thomas, Micha and Samuel, here in the traditional Austrian costumes. And then my brother Gerhard and his wife Sophie, and Paul and Karl, our nephews. And then obviously Gerhard's family as well. Unfortunately, her parents have both passed away. And her sister Gudrun and her husband Werner, and our nieces Nora and Jana, and our late sister Gail, younger sister, who unfortunately passed away due to cancer a few years ago. And then a big thank you goes also to our church family. Church families in South Africa, church family in America, in Austria, and also church family here in England. And they were great support wherever we went, and we always felt at home, particularly in the case that we didn't have any children. And then finally, I want to say a big thank you to my wife. She is my best friend. She's my soulmate. She's my wife now for almost 34 years. But we know each other for almost 40 years, and it has been great to being together. And without you and without your support and encouragement, I wouldn't have been here. I wouldn't have gone to any of these foreign countries, and you were a great support and inspiration. Thank you so much. Danke, liebe Gerhard. And then I want to come back to Austria and show you something you can do in Austria. These are our nephews. One is Thomas and the other one is Micha, and they do wakeboarding, not in the Caribbean. This is an Austrian lake just a few kilometers away from my parents' place, and you can see the water. It's unbelievable. It's crystal clear. You can see into it, you can swim in it, and you can drink it, the water. And this is them doing wakeboarding, not me. So thanks again for being here, thanks for your attention, and thanks for listening to me. Please join us for soft drinks and cannabis reception outside, and everybody here is also invited to join us to the Belmer pub after 7 for drinks and nibbles. And thanks again for your attention, for being here.
Well done. done, Hans Michael. That was an inaugural lecture to do us all proud. So thank you so much. I think it's my duty really to just sum up some of the things that we've heard. So if you bear with me for just a few moments. You were slightly sceptical, I have to say, about our triple helix, but you have just epitomised the triple helix. You told us all about the people in the middle. You told us about your research, your enterprise, your spin-out company ideas, and your education. And you've educated us all on history, geography, culture, creativity. You've covered the lot. I thought it was fascinating, your story of being a medical student in Graz, and I thought our students could learn quite a lot from that. And the sort of image of you being examined in public and having to make a diagnosis was quite something. And it did strike me that you're a carpenter, you're a doctor. Why weren't you an orthopaedic surgeon? I'm just really confused by that.
I hated standing in the theatres.
But anyway, I think the world of asthma is better for the fact that you weren't an orthopaedic surgeon and you chose science, and you've told us some really, really fascinating science. You've done amazing sort of discovery work there, and hopefully that will really lead to an impact on the treatment of what is a very common disease. I wasn't aware of all those stats. I knew it was common, but that is still quite shocking to hear. So well done. I think you've given hope to many and entertainment to certainly the assembled group here. So thank you very, very much for your inaugural lecture, and welcome.